Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Isma Adlinda binti Ismail. My metric number is 180005. What is Bursa angle? Bursa angle, or also known as polarization angle, is an angle of incidence at which light with a particular polarization is perfectly transmitted through a transparent dielectric surface with no reflection. Theoretically, a beam of light on the dielectric transparent material can be resolved into parallel and orthogonal components. Birusa discovered that at particular angle of incidence, theta b, the reflection coefficient of p component goes to 0. When unpolarized light is incident at this angle, the light that is reflected from the surface is therefore perfectly polarized. In this condition, the reflected and transmitted beams are orthogonal to each other. This theory is based on the Snell law. Tangent theta b equal to n, where n is reflective index of the material.
Hi, my name is Muhammad Syamil bin Sanab and I will be presenting the simulation of Breuer angle determination. This is the simulation. However, I'm going to talk a little bit about how to set up in real life. First, we set up the system like so. The emitter, it's emit helium laser. The polarizer, the material holder for holding the material. The detector from it's detect the reflected laser from the material, and the current output unit, so it can read the output current. So in lab, we need to make sure that the reflected material is vertical and centered over the axis of rotational and rotational stage. The reflected material was set up so that it was 90 degree on the protector. The incident ray from the what you call the emitter using helium laser source hit the surface perpendicularly so that it can reflected beam go back to the detector for the lab. So now we go to the simulation. We choose the medium, choose air, but we can use helium, hydrogen, carbon dioxide, and so on. And topaz material. If we switch off the light, we can see that the output is shown. In real life, we need to set up the system such as it's in a perfectly dark room, no light whatsoever. We know that Brewing angle can be calculated using Brewing angle equation, and it is shown in this show result. We can see that the Brewing angle is 81.11 degree. However, in this experiment, we can play around with the rotating glass plate. We can see that the plate is rotating. We can map up the graph angle versus input, and we can pinpoint the Brewing angle from the graph. Precaution: the laser beam should not penetrate our eyes. We should not pointing the laser into our eyes, because this can damage our eyes. The laser should be operated at constant voltage 220 volt, so that it can to avoid flickering. The laser should started 50 minutes to warm up so that it can have a constant results. The scale of vernier in this thing should be rotated slowly. And last but not least, but the most important thing, the room should be perfectly dark. That's all for me. Thank you.
Assalamualaikum and have a good day to Dr. Nadia. My name is Nur Hazanita, and now I will represent how we get a result of the data. Okay, first we choose only one medium for this experiment, which is air, but we choose two materials for this experiment, which is topaz and crown glass. So let's look how we get a Brewster angle for topaz. Okay, the angle we obtain from what we determining in the stimulation experiment, and the current or the reflected power also we obtain from the stimulation from the current output unit device. And then we put air as a surface reflected, and then a toothpaste as a reflected index. So from the ratio between a reflected reflected index of a reflected surface, we get a Brewster angle for a toothpaste is 58.1. Same goes when we change the material to the crown glasses, but we keep the medium same, and then we got the angle and the current from stimulation like before when we use the toothpaste. So we can get an angle and the reflect the power from the current output unit device. So for the Brewster angle for the crown glass, we use air as in reflected surface, and we choose a crown glass as index reflected. So from the ratio we got the Brewster angle 56.65. Okay, why Brewster angle for crown glass is less than Brewster angle for toothpaste? Okay, it is because when we saw a physical for this material crown glass, it's more the surface is more clear than a toothpaste surface. Like a material of toothpaste is more complex than glass crown glass material. So that's why the reflected or Brewster angle is more bigger than crown glass Brewster angle. And then meanwhile we can know the toothpaste reflected index is bigger than crown glass reflected index. Let me see, 5.52, and that's why the reflected index for toothpaste is bigger than crown glass, so that the Brewster angle also affected from the reflected index. That's why the toothpaste have a Brewster angle bigger than crown glass Brewster angle. Okay, that's all from me. Thank you.